Good morning. Today we are going to solve sub 317 of the book Fundamentals of Electric Circuit Sadiku. This exercise asks me to determine the current I1 in the circuit shown in the figure. I suppose that soon it is a book error, because here we are Martin, the I being. This must be the theory that we are going to do. So, we have to apply new analysis. So, the first thing I advise is to identify the direction of the currents in the 20 nodes monthly. For example, I'm going to look here. Here there is a voltage between this point and this point that is 60 volts, and over here I say that a current is going to come in this direction. True? The other current goes upwards, that the I sub 0 must be the same as it comes like this. There is the I sub 0. And it comes this way. The current arrives at this node here, and let's observe that here there is a pending current source that also reaches this node. Therefore you just got a current in a star, right? These two arrive here. From there the other current comes out. This current reaches this point and meets this current that comes here, and they have to take a direction, I suppose, which is in this direction. Good. Okay, the other thing we have to do, we already have the direction of the currents marked. I'm going to give them names. I'm going to call this one 1. I'm going to call the little one here I2, and I'm going to call the one who comes here I3. The nodes are going to be this one. I'm going to put this one. Well, this one no longer has values of 60. I'm going to put it here in node B1 and in node B2. The first thing I'm going to do is the analysis on node B1. I'm going to mark the currents that enter the same as the currents that leave, the currents that enter at this point of the I sub 0 and the I2. 0 plus 2. That will be equal to the 40 that comes out, which is 3 from there. In the I, the 40 I0, the one that comes from here, which is the same one that comes from here, is going to be equal to, we know that here there is a tension, which is the tension at this point, which is this same one, which would be 60 less. A tension B1 on the 4 shoulders. This is the current IC plus the current I2, then the one that comes here, which is going to be B2, the attention here, B2, minus the attention B1 over the 2 ohms. And that is the current that enters at this point, and 0 plus IB plus I2, this is I0, this is I2, the current that comes out is going to be the same. That's how it is. This current has over here. And I'm going to take like B1, about 8 ounces. Ready. I start applying something, right? This would be 60 over 4 minus B1 over 4 plus B 2 over 2 minus P 1 over 2 equals P1 over 8. Therefore, everything can happen to the other side of the same. I'm going to move all this over there. I'm going to write it here, P1 over 8. This that is negative to be with positive would be more P1 over 4 minus A. Well, here's another B1. I'm going to put more, okay? This one here is negative. I'm going to pass it to the other side. The same, B1 over 2, minus B2 over 2, that's going to be equal to 61/4, that would be 15. Well, now what I'm going to do is chop. Well, to finish, Leo will apply to you, right? Or we can simply multiply this whole by 8, very typical. All this expression both sides of the same, obviously. On the other hand, I am going to obtain that it would be P1 plus all of the B1 plus 4 B 1 minus would be 4b 2 equal to 15 times 8 would be 120. Okay. Now, b1 plus 2 plus 3. This would be 7. b1 minus 4b2 equals 120. This would be equation 1. Now, in node 2, since I already have all this, I'm going to delete it. If you have any questions, you can rewind the video by putting this here. CTB1 minus 4P2 equals 120 to finish addressing this. Now, in then mode, we already did the navigation here, right? B2, come here, because we are going to do the same. The currents that enter this point are the same as those that leave. What enters would be 3 and sub-0 plus. The current M1 is going to be equal to the current M. Well, now, 3I sub-0 would be 3. The current I sub-0. The current sub-0 for the example here, right? Which would be 60 minus B1 over 4. 3 times 60 minus B1 over 4. This is plus the current I 1 and the current I 1 that comes this way in this direction, which would be 60 minus B2 over 10. All of that is going to be likewise. These are the two currents that enter. The same as the one I told you is the one that leaves, which would be B2 minus B1 over 2. So, we apply something. Here we have it would be good 3 times 60 divided by 4 would be 43 times 60 divided by 4 would be 45, minus 3/4 of B1. 69/10 would be 6 plus 6 minus B2 over 10 equal to B2. I missed putting the 2. I don't know why B2. Well, B1 over 2. It's corrected, B2 minus B1 over 2 ends. True? Maybe I ordered it accidentally. Good. So, we continue applying something. I'm going to pass the ones that have the variable to the other side the same and the ones that are here on this side. That's what I'm going to have here. I'm going to order here. Here it would be minus B1 over 2. Minus B1 over 2. Minus B1 over 2. I'm going to pass this one that has B1 to the other side just like that. It would be 3B1 over 4 more than B1 4. Yes? I'm going through this there. The other would be B2 plus B2 over 2, which would be this same one. The sign does not change because it is already there. And I pass this that is negative to the other side, it would still be plus B 2 over 10. 2 equals 45 plus 6, there would be 51. Okay. Now operate those that have B1, 3/4 of B1 minus a half of B1. This is going to give me a quarter TB1, please, you can verify yourselves. And B2 would be a half plus a single 1/10. This is going to give me 3 points. TV2 this equals 51. Do you know how to do my equation? 2. And well, here it would be a quarter of B1 plus 3 fifths of B2 to the 51 point, and we now have our two equations too. 5. Well, I'll solve it for a can. Here it would be 7 minus 4, a quarter, 3/15. 7 space minus 4 semicolons again in parentheses 1 divided by 4, 1 over 4. Step 3 out of 5 3 days. And here I'm going to put the 120 semicolon and 51. The voltage B1 is going to give me 53.07 and the voltage 2 gives me 62.88. I put it here. P1 gives me 53.07 and B2 is going to give me 60 and 2.88. Okay, so the exercise is what the zero ISO current asks us for, which is the one that comes from here, which comes from here and passes through here. We already have B1 and B2. But we only need B1. The current and sub-zero will be equal to the voltage that is here at this point, which is 60 volts, minus the unit I have right now, minus B1, which is 53.07 over the 4. So it's there. Sub-zero. It's going to give me 1.73 amps. Please check on cover about resistance equals current. Ready, mates. See you in the next video.